Example 8 is our last example in section 5.6 on the real zeros of a polynomial function. We're to use the zeros to factor f over the real numbers. So we want to factor this by using the zeros. So we have to find the zeros. We'll start with our steps. The maximum real zeros is how many? 4. Positive real zeros, count the sign changes. Positive to negative, there's 1. Negative to negative, no change. Negative to positive, there's 2. Positive to positive, no change. So there's 2, or if they're non-reals, a pair of non-reals, there won't be any. Substitute in negative x, changes the sign on all the terms that have an odd power for x. So 2x to the fourth, negative x third changes to positive x to the third, minus 5x squared, minus 2x plus 2. The only ones that changed sign were the x to the third and the x to the first. Count the sign changes. Positive to positive, no change. Positive to negative, 1 change. Negative to negative, no change. Negative to positive, there's another. So the negative real zeros is also 2 or 0. Okay, so we could take a minute and analyze what the different scenarios are for zeros. Let's make a little table. You don't have to do this every time or anything, but I just think it's a nice way to illustrate. Okay, so we have positives, we have negatives, we have non-real, and then of course our total. One scenario is we have 2 positives, 2 negatives, no non-reals for a total of 4. Another possibility is we have 2 positives but no negatives, so therefore there's 2 non-reals for a total of 4. Another possibility is no positives but 2 negatives and 2 non-reals for a total of 4. And the last possibility is there are no positives, no negatives, 4 non-reals. Okay? So these are all there are 4 different potential outcomes in positive and negative real zeros, just to make sure you understand what all this means. Okay, P, factors of the constant, which is 2, so plus or minus 1, plus or minus 2. Q, the factors of the leading coefficient, which is also 2. So P over Q will be plus or minus 1, plus or minus 2, and then plus or minus 1/2. Okay, well, I'm just going to start with 1. You don't have to, that's just what I'm choosing to do. Our coefficients are 2, negative 1, negative 5, 2, and 2. 1 times 2 is 2, add, multiply, add, multiply, add, multiply, add, and I got lucky, look at that. So 1 is a real zero. That's one of my positives, so that means there is definitely another positive. And 0 is not going to be an option for positives because it's either 2 or 0. I found 1, so there's definitely another one. Now we're down to 4 terms here. Let's write those terms. It was x to the fourth, now it's 2x cubed plus x squared minus 4x minus 2. Let's set that equal to 0 and try grouping. It may or may not work, but it's worth a try. If it doesn't, we'll go back to synthetic division. Factor out x squared, leave behind 2x plus 1. Factor out a negative 2, leave behind 2x plus 1. It's going to work. So we have 2x plus 1, x squared minus 2. All right, so 2x plus 1 equals 0, 2x equals negative 1, x equals negative 1/2. Notice that's in our list. It's a negative. So we found a positive, we found a negative. There's definitely another positive and another negative and no non-reals. All right, x squared minus 2 equals 0, x squared equals 2, square root of x squared equals plus or minus the square root of 2, so x equals plus or minus the square root of 2. So what have we found here? These are real. They're just not on this list because they're not rational. But remember I said if we do have something like the square root of 2 or square root of 7 or whatever, we hopefully can find them at the end when we we break it down into quadratics like this. So these are also real solutions. And notice a positive and a negative. So our real zeros that we found are 1 with a multiplicity of 1. It just occurred once. Negative 1/2 with a multiplicity of 1. Square root of 2 with a multiplicity of 1. And negative square root of 2 with a multiplicity of 1. Those are our real zeros. So we had 2 negatives, 2 positives. It said to use these zeros to factor. All right, so let's write our factored form. F of x equals. I'm going to leave a little space for a in case it's not 1. If 1 is a 0, then x minus 1 is a factor, and it's raised to the first power because the multiplicity is 1. If negative 1/2 is a 0, then x plus 1/2 is a factor. Then we have x minus the square root of 2 and x plus the square root of 2. And then I look back at my original and say, if I'm going to get x to the 4th after multiplying all these, 2x to the 4th, then a has to be 2. I'll need that 2 to ultimately get this leading coefficient, and then that'll take care of everything else also. Okay?